Recording has started.
Okay. So today we're going to continue on with measurement. Again, getting away from the errors and significant digit stuff into the stuff you're more familiar with and you're going to use more. We want to look today at combining measurements, operations with measurements. Now in standard measurements, it is very common for us to have dual units. What do I mean by dual units? Well, something might be listed as 6 feet. I'll do it with words rather than just a symbol, but 6 feet, 8 inches. Well, why would we do that? Well, because 80 inches is a large number, hard for us to visualize. 6 feet is something we're more familiar with. Adding the 8 inches onto it visually is easier for us to conceive. So the question might be, well, why don't we just change it into just all feet? Well, if we tried to convert that all into feet, in order to convert feet and inches into just feet, we have to convert the inches. Well, 6 feet, 8 inches. What we would do is we would take that 8 inches and we'd make it feet by just putting it over 12. So that becomes 6 and 8/12 of a foot. That reduces to either 6 2/3 feet, or as a decimal, 6.6666666. You get the picture. It doesn't divide out neatly. We have this either to deal with a fraction or an ugly repeating decimal, and we don't want to do that. We want to avoid that. So we use the dual units, sometimes even triple units with yards, feet, and inches. So it's because of that multiple unit expression of lengths and stuff in our standard system that we often will, the operations can be a little bit tricky. If we start out with something like 7 feet 3 inches, and we're going to add to that 4 feet 8 inches. Just like any whole number, we have to only, well, when we add or subtract, we can only combine things that have the same name. So that means the same label, same unit. So inches can combine with inches, feet can combine with feet. In fact, if you think back to the second day when we had our whole numbers written out in long form, hundreds, tens, and ones, this looks very similar to that. Just like any whole number, we're going to start on the right and work our way backwards to the left. We'll do 3 inches, and 8 inches is 11 inches. Now, one big difference here is if that were a whole number, we'd have to carry. But for feet and inches, we don't carry until we hit 12 inches. That's less than a foot, so we're going to leave it as just the 11 inches. Then 7 feet and 4 feet is 11 feet. We had 11 feet, 11 inches. Now, of course, it doesn't stay that easy. We mentioned carrying. We might have 5 feet 9 inches plus 3 feet 11 inches. So as always, we start on the right and we work our way back to the left. 9 inches and 11 inches is 20 inches, which is bigger than a foot. Now, we could think of it almost like our fractions of just using a denominator of 12, figuring out what our whole number would be and our pieces left over. I think it was like 20 over 12. Well, 12 goes into 20 once with 8 left over. We just don't want to reduce that. We want to leave that denominator as 12s. That gives us 1 foot and 8 inches, because 12 went into 20 once with 8 inches left over. And just like whole numbers or fractions or whatever, we're going to keep part of it here. This is the inch column, so we keep the inches, and we'll carry the feet to the next place value. 1 and 5 is 6, plus 3 is 9 feet. So we're at 9 feet, 8 inches. You might have something like 4 yards and 2 feet, plus 7 yards and 2 feet. Again, we start on the right and we work our way back to the left. 2 feet and 2 feet is 4 feet. Now, when we're dealing with measurement, we always have to look at what the next measurement is, what the next column to the left is, to decide if we have to carry. 4 feet doesn't seem that large, but we look at that next column, it's yards. There's only 3 feet in a yard. So this is bigger than a yard. So I can break that down. 1 yard would take up 3 of those feet, and there'd be 1 foot left over. We have 1 foot, we carry the 1 yard. 1 and 4 is 5, plus 7 is 12 yards. That's 12 yards and 1 foot. Well, I have to throw in something that you're probably not familiar with. So let's do something like 3 rods and 4 yards, plus 6 rods and 3 yards. Start on the right and work our way back to the left again, as always. 4 and 3 makes 7 yards. Well, we know that it takes 5.5 yards or 5.5 yards to make a rod. So that 7 yards is enough to make 1 rod. 1 rod again was 5.5 yards, so we take that away from 7, that would be 1.5 or 1.5 yards left over. So we'll keep the 1.5 yards and carry the 1 rod. 1 and 3 is 4, plus 6 is 10 rods. Well, we mentioned the possibility of triple units, 3 units. We might have something like 5 yards, 2 feet, 8 inches, plus 2 yards, 2 feet, 7 inches. Now again, it's important to start on the right and work our way back to the left. 8 plus 7, I should say, is 15 inches. Well, that is 1 foot. That'd be 12 inches with 3 inches left over. So we're going to keep our 3 inches and carry the 1 foot. Now we've got 1, 2, and 2 is 5 feet. That's bigger than a yard. We can get 1 yard out of that. 1 yard takes 3 feet, so there'd be 2 feet left over. So we're going to keep the 2 feet here and carry the 1 yard. 1 and 5 is 6, plus 2 is 8 yards. We have 8 yards, 2 feet, 3 inches. Any questions? Well, let's look at subtraction. I have something like 9 feet, 7 inches minus 3 feet, 5 inches. Just like addition, we can only combine things that have the same name. Just like whole numbers, we're going to start at the right and work our way back to the left. 7 minus 5 is 2 inches. 9 minus 3 is 6 feet. Of course, it doesn't stay that simple. We can run into 9 feet, 2 inches minus 3 feet, 11 inches. We go to subtract. 2 minus 11 cannot be done. So we're going to have to borrow from the 8 feet. This is going to become 7 feet. Now, similar to our fractions, when we borrowed, we can't just put a 1 in front of it. We actually have to look at how many pieces are in what we just borrowed. Well, 1 foot contains 12 inches. So we have to add 12 inches here to get 14 inches. Now it's 14 inches minus 11 inches is 3 inches. 7 feet minus 3 feet is 4 feet. 4 feet, 3 inches. Might have 7 yards and 1 foot minus 3 yards and 2 feet. As always, we start at the right, work our way back to the left. Well, 1 foot minus 2 feet can't be done. We're going to borrow from our yards. 7 yards becomes 6 yards. Well, what we borrowed, 1 yard, contains 3 feet. We add 3 feet to that 1, it's now 4 feet. Correct? 4 feet minus 2 feet is 2 feet. And 6 minus 3 is 3 yards. Give us 3 yards and 2 feet. We might have 7 rods and 2 yards minus 4 rods and 5 yards. So we go to subtract. 2 minus 5 can't be done. So we're going to borrow from the 7 rods. That'll become 6 rods. That 1 rod we borrowed contains 5.5 yards. So 2 plus 5.5 is 7.5 yards, or 7.5. We subtract 7.5 minus 5 is 2.5 yards. 6 rods minus 4 rods is 2 rods. 2 rods and 2.5 yards. We might have 8 yards. We'll go let's go 1 foot 3 inches minus 2 yards, 2 feet, 11 inches. So, again, we go to subtract. 3 inches minus 11 inches can't be done, so we're going to borrow from the foot. That now is 0 feet. We add 12 inches here to get 15 inches. So 15 minus 11 is 4 inches. Well, we tried to do 0 feet minus 2 feet can't be done, so we're going to borrow from the 8 yards. That's now 7 yards. We add 3 feet here to get 4 feet. Now it is 4 feet minus 2 feet is 2 feet. Sorry, not 4 feet. That should be 3 feet. 3 feet minus 2 feet should be 1 foot. 0 minus 3 would have been just 3, not 4. So 3 minus 2 is 1 foot. 7 yards minus 2 yards is 5 yards. 5 yards, 1 foot, 4 inches. Multiplication is a little bit trickier. There's 2 types of multiplication. We can have a length times another length, or we can have a length times what is referred to as a scalar. Scalar means it's no unit. It's not a measurement. It is a counting number. Let's look at the length times the length first. So if I start out with something like, 4 feet 3 inches times 2 feet 6 inches. If I were to try to multiply that out the way it is, I would have to do the 6 inches times 3 inches is 18 inches squared. Then I'd also have to do the 6 inches times the 4 feet, which would give us something called 24 inch feet. Now that's actually a unit. Inch feet is a unit, but we don't use it anymore. It's a strip that's 1 inch wide by 12 inches long. It used to have some applications, but it doesn't anymore. We just plain don't use it. Then we'd have to do the 2 feet times the 3 inches to get 6 more inch feet, and 2 feet times 4 feet is 8 square feet. And we'd add all those up to get 8 square feet, 30 inch feet, and 18 square inches. Well, that's pretty ugly. And trying to actually visualize what that size is and how much that covers is next to impossible. The mind just can't convert all those units and put them all together and get a cohesive picture of that size. When we do square inches or square feet, we tend to not use that dual units anymore. We just use a single unit. It's either all square feet or all square inches. So for something like 4 feet 3 inches times 2 feet 6 inches, we would either convert it all into inches or all into feet. I'm going to convert it all into inches. Again, we think almost like our mixed numbers and our fractions. Think of this as being twelfths. 4 times 12 is 48 plus 3 is 51 inches. Just like converting that mixed number into an improper fraction. 2 times 12 is 24 plus 6 is 30 inches. Now I multiply. 51 times 30 is 1,530 inches squared, or square inches. Or the other option we said was we could convert everything into feet. To do that, same thing. We're thinking about mixed numbers in fractions. 4 feet 3 inches is just 4 3/12 of a foot. We take the inches into the feet by putting it over 12. And of course, that is just 4 1/4 feet. 2 feet 6 inches would be 2 6/12, or 2 1/2 feet. I believe that comes out to 10 5/8, but I'm going to check it here. It is 10 5/8 square feet, or 10.625 square feet. Now you'll notice here, by the way, since we've got this example up here, the conversion factors don't seem quite right. If I take that 10 5/8 square feet, if I take feet times 12, I should get inches, right? But I don't get the 1,500. In fact, if I multiply by 12 again, I'll actually get the 1,530 that I had over here. The reason being is these are not inches and feet anymore. These are square inches and square feet. So we're going to have to adjust our conversion factors when we get to those units. We'll talk about those next week at some point. But be aware that square inches and square feet do not have the same conversion factors as regular linear feet and linear inches. So this is what would happen if we were going to multiply two measurements. We would just make sure they were both the same unit, multiply them, and have a unit squared. So we want to spend more time looking at a measurement times a scalar. 7 feet 8 inches times 5. So I have pieces that are 7 feet 8 inches long, and I need 5 of them. I'm trying to find the total length needed. Like any other operation, I start on the right and I work my way back to the left. 5 times 8 inches is 40 inches. So now we do have to break this down into feet and inches. We can use that same strategy as changing an improper fraction to a mixed number. There's 12 inches in that foot, so we're going to do 40 divided by 12. 12 goes into 40 3 times. 3 times 12 is 36, so there's 4 left over. Well, this is the feet. That's 3 feet. And this is what's left over. That's the 4 inches. You can see the same process as for dealing with improper fractions to mixed numbers. So we'll keep the 4 inches, and we'll carry the 3 feet. 5 times 7 is 35, plus 3 is 38 feet. 38 feet 4 inches. We have 3 yards and 2 feet times 4. 4 times 2 feet is 8 feet. Well, again, we need to figure out how many yards are in that. There's 3 feet in a yard, so we would be dividing by 3. 3 goes into 8 twice. 2 times 3 is 6. There's 2 left over. So that's 2 yards with 2 feet left over. So we will keep our 2 feet and carry the 2 yards. 4 times 3 is 12, plus 2 is 14 yards. 14 yards, 2 feet. Well, since we're having fun, we just will do our rods and yards. Let's do 3 rods with 4 yards times, let's just do times 5. 5 times 4 yards is 20 yards. Well, again, that is bigger than a rod. A rod is 5.5 yards. 5.5 goes into 20 3 times. 3 times 5.5 is 16.5. I have to add a decimal point and a 0 there to subtract. We get 3.5. So it's saying that this is 3 rods with 3.5 yards left over. So we'll keep our 3.5 yards. Carry the 3 rods. 5 times 3 is 15, plus 3 is 18 rods. A lot of people get confused when we throw fractions on our inches like this. 7 feet, 9 3/4 inches. Let's go times 7. Well, 7 times 9 3/4 does take a little bit more work. 9 3/4 times 7. Do 9 times 4 is 36, plus 3 is 39/4. 7 over 1. 39 times 7 is 273. 4 times 1 is 4. Now we have to break that down. It comes out to be 68 1/4. But let's divide it out. 273 divided by 4. 4 does not go into 2, so we leave it blank. 4 goes into 27 6 times. 6 times 4 is 24, so subtract to get 3. Bring down the 3. 4 goes into 32 8 times. That's 32, with 1 left over. So that is 68 1/4 inches. Now that's still just inches. We still have to break that into feet. Now many of you are probably familiar enough with feet and inches that you know that 60 inches is 5 feet. So if I subtract 60 from here, that would leave me with 8 1/4 inches. So I'll keep my 8 1/4 inches. And my 60 inches was my 5 feet, so I'll carry my 5 feet. 7 times 7 is 49, plus 4 is 54 feet. So that is 54 feet, 8 1/4 inches total. Division. Well, division is the one operation that we start on the left and we go to the right. And remember, we said the reason was we're doing that repeated subtraction, and we want to subtract the biggest values we can, the biggest packages that we can first. So if I take something like 17 feet 8 inches, I'm going to divide it by 4. Now, just like multiplication, if we were dividing two measurements, we'd make sure they had the same units. But the opposite of multiplication, when we multiply two of the same units, we get a unit squared. When we divide two of the same units, the units disappear. We get a scalar. So we're going to focus on taking a measurement divided by a scalar, or counting number. 4 goes into 17 4 times. That'd be 4 feet. 4 feet times 4 is 16 feet. So there's 1 foot left over. Before we can bring down our 8 inches, we have to convert that 1 foot into 12 inches. Now we can bring down our 8 inches and combine it with the 12. We have 20 inches. 4 goes into 20 inches 5 times. That's 4 feet 5 inches. So we might have 30 feet 4 inches divided by 7. Well, 7 goes into 30 feet 4 times. 4 feet times 7 is 28 feet. Well, we subtract there, we have 2 feet left over. Well, before we can bring down the 4 inches, we convert that 2 feet into inches. 2 times 12 is 24 inches. Now we can bring down the 4 inches with our 24. That's 28 inches total. And now we can do 28 divided by 7 is 4 inches again. So 30 feet 4 inches divided by 7 in 7 equal pieces. Each piece would be 4 feet 4 inches long. So the difficulty with dealing with standard measurements came from the fact that we had those dual units or sometimes even triple units to deal with. In the metric system, we don't use dual units. There's no dual units at all. We would never list something as being 2 meters, 83 centimeters. We just don't do it. Like we said, we had to do that in the standard system to avoid some really ugly decimals or fractions. But the metric system was set up so that all those conversions work out nice and neat. 2 meters, 83 centimeters can either be listed as exactly 2.83 meters or 283 centimeters. There's no need to use dual units because there's not going to be any ugly repeating decimal or fraction that we would have to work with. We get pretty neat numbers to work with. So in the metric system, all we have to do for our operations is to make sure we have two measurements that are the same units. If we have 3.8 meters plus 170 centimeters. Oops, I'll put my 0 in there. 170 centimeters. Either I'm going to have to convert meters to centimeters, or I'm going to have to convert centimeters to meters. Or maybe I convert both of them to a different unit that's the same and then combine them. To know what conversions need to be made, I need to know what I want my answer in. If we're told that we want our answer to be meters, well, then we are just going to leave the 3.8 meters as meters. The 170 centimeters are going to be converted to meters. Remember, we had meters, decimeters, centimeters on our chart. To get from centimeters to meters is 2 spots to the left. My decimal point is going to move 2 spots to the left. That is 1.7 meters. 3.8 plus 1.7 is going to be 5.5 meters. And for all of our metric operations, that's the way it's going to work. We just have to have the same units. Just like with standard units, we have to be aware of what we're doing. Addition and subtraction, we have to have the same units. We're going to combine the numbers and keep that same unit. For multiplication and division, it's best if we're using 2 length units, they should be the same length unit. But we can have a length unit and a mass unit together. That is fine. But if I have something like 5 meters times 3 meters, as we said, we're going to do 5 times 3 is 15, but also combine the names, the units. Meters times meters will be meters squared. Or if I have 7 square meters in area times 4, a scalar. Well, 7 times 4 is 28. Meters squared times nothing, there's nothing to combine it with. It's just going to stay meters squared. I might have 3 meters squared times 6 meters. Well, we combine the 3 times 6 is 18. Meters squared times meters is meters cubed, or meters to the 3rd power. We get a volume. Or we might have something simple like 8 meters times 2. Again, 8 times 2 is 16. Meters times nothing, there's no unit to combine it with, that just stays meters. So there's a whole bunch of different units we can end up with when we multiply. And the opposite side of that with division, we might have 8 meters divided by 2 meters. Well, 8 divided by 2 is 4. The meters divide out. That's just 4. That's like saying if we have something 8 meters long and we need to cut 2 meter pieces out of it, how many can we get? Well, we're going to get 4 of them. We might have something that's 12 square meters in area and divide it by 3. If we cut that into 3 pieces, 12 divided by 3 is 4. Meters squared divided by nothing stays meters squared. We'd be cutting into 3 pieces that are each 4 meters squared. We might have 15 meters divided by 3. Well, 15 divided by 3 is 5. Meters divided by nothing is still meters. Or we might have 20 meters squared divided by 5 meters. 20 divided by 5 is just 4. Meters squared divided by meters is just meters. So you have to be aware of what units there are out there. So for homework, I'm giving you a little bit of extra time today because we got quite a considerable amount of homework here. 2 different sections. One section out of the big book for everybody. That section is going to involve page 283 through 285. This is actually exercises 8-2A and 8-2B. Do the odds on those. Page 285 through 287. This is exercise 8-2C and 8-2D. Please do the odds there. Now, the first 6 problems on each of those are reviews. So if you want to skip 1 through 6, that's not a big deal. Page, where am I at here? 292 through 295. Exercise 8-4, the odds there as well. And page 317 through 318. Exercise 9-4, the odds. And then finally, last piece out of the little book. Unit 20, the odds. If you haven't done it yet, there's a quiz out there that was due yesterday, or was due at noon today, I guess, actually, from yesterday. Make sure you get that turned in. I graded them this morning. There were still a few not turned in, so make sure you're done with those. There will be a new quiz on Monday, but you won't have to worry about that till Monday. I'll get it posted sometime over the weekend here. Otherwise, we've got plenty to work on there. I will stay on the network for a while if any of you have any questions. Otherwise, as I realize since you're at home, you're probably going to want to take off. If you want to get going, that is okay as well.